All right. Chapter 9, Lesson 4, hands-on, using models to add unlike fractions. Okay, so this one is straight models. There's no math way for this one. Okay, so if you have your fraction strips or fraction bars, this is where you're going to be using them. Okay, unlike fractions have different denominators. So 1/2 plus, let's say, 2/4. 2 and 4 are the denominators. They are different. They are unlike. That's what they mean by that. So before you can add them together, one or both of them must be renamed so that they have a common denominator. You have to have the same size pieces in order to put them together. It's kind of like Legos. You got to be able to stack the same size on top of each other. They can't be different sizes. They have to be the same size. So, let's look at our first problem here. We have, to finish building a birdhouse, Jordan uses 2 boards. One is a 1/2 foot long and the other is a 1/4 of a foot long. What is the total length? Total, add, clue there, of the boards. So, if we were to model this, first we need the first model, which is what is 1/2. So, I'll grab my model. 1/2 plus 1/4. There's my 2 models. That's how much board he has right now. However, you can clearly see 1/2 size pieces and 1/4 size pieces are completely different. Okay? We need them to be all the same size or all the same color if you're using the pattern or the fraction strips or bars. So, if I look here, this is where you kind of got to play around a little bit, or if you know of fractions that mean the same as a 1/2, or if you look, this is a fraction strip, I just printed it off, straight as can be. I'm looking for a 1/2. So if I look down my page to see a 1/2, I can see all the fractions that would be equivalent to a 1/2. So I can see 2/4 is the same as a 1/2. I can see 3/6 is the same as a 1/2. I can see 4/8 is a 1/2. 5/10, 6/12. All of them are showing the same amount on the line. But I've got to remember, I'm working with 4ths as well. So if I've already got a 4th to work with, and I know that 2/4 are the same as a 1/2, that's going to be what I'm going to swap out. So if I take my 1/2 and I swap it out for 2/4, you can see it's the exact same size. That's what I'm going to do. So I swap out the 1/2 for the 2/4. So I'm still showing a 1/2, which would be these 2, plus a 1/4. But now I'm all same size pieces. I'm same denominator. It has to be the same denominator. So now that I have all of my pieces the same size, same color, I can put them together. Count, which is step 3. So there are 3 of the 1/4 fraction tiles, and that represents 3/4. So a 1/2 plus a 1/4 means the same as 3/4. The total length of the boards is 3/4 of a foot. And my dogs are barking. All right, let's look at number 2. Hey, Tilly. Hey, Till. Tilly. Enough. Come here. Come here. All right, now if we look at number 2, the try it. We have Munna's family ate 2/3 of a strawberry pie, and Brendan's family ate 3/4 of a different strawberry pie. How much did they eat all together? Again, clue word for we're going to be adding. Again, we're doing the models here. So I need to model each part. So Manas did 2/3. So I need to show that. Where's my third pieces? There we go. So 2/3. And Brendan was 3/4. See if I've got the room here. So that's how much they ate of the pie together. However, we don't have same size pieces. We don't have same color. We need to find a fraction, a common denominator for 3 and 4 that will be the same amount shown here. Well, 3 and 4, I know, can use 12ths. So I know I can get to 12 if I multiply 3 by 4, and I know I can get to 12 if I multiply 4 by 3. So I'm going to take all of my little 12th pieces here, and line them up. Oops. I'm going to run out of room. All right, I'm going to move this down. All right, I'm running out of room, so I'm going to scoot this. Oops. All right, so here's all my 12ths. And again, when you do this, you line them up right against each other. Okay, I need some more. All right, so now I'm showing I have the same amount of fractions here. I'm showing all in the same denominator, all in the same color, pink. So now, all we need to do is to count them. So that was number 2. Number 3 on our paper says count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 of the 1/12 fraction tiles in all. This represents the fraction 17 out of 12, or I know that 17/12 is an improper fraction, and I know if I take out 12/12, that's a whole, I will have 12/12, and then that left over 5/12, which is still meaning the same as 17/12. But now I see that it is 1 whole and 5/12, which is what they're showing here. So 2/3 plus 3/4 equals what we got, 1 and 5/12. They ate 1 and 5/12 strawberry pies all together. Okay? All right, let's look at the practice. And again, you're using the models here. There's not math way going on here. We're focusing on the pictures, the models to help us see. So let's look at the first one, number 4. We have 2/3 plus 1/6. So again, start off modeling the fractions as they are. So the first one, I need 2/3. Then I need a 1/6. So I'm showing 2/3 plus 1/6. Clearly, I'm not same size. Clearly, I'm not same color. However, if I see thirds and 6, I'm just curious. Let's see here. 1/3 is the same as 2/6. Again, if you were to look at our fraction strips, if I'm looking at a 1/3 and I just kind of block off the rest, I see 1/3 the same as 2/6 or 4/12. So I could change them all to 6 or I could change them all to 12. Since I already have a 6 here, I'm going to go with 6. So 1/3 is 2/6. I need another 1/3, which is the same as 2/6, and that 1/6 that we had. So now I'm going to take away the 2/3 and 1/6 because we converted them. We changed them all to same size pieces. So now I just need to look. I have 1, 2, 3, 4, 5 of my 1/6 pieces. So simplest form, that's it, draw the model. So now I need to show my model here, which is exactly what we just had. So I went from 2/3 and 1/6 to 5/6. So if I'm drawing my model, which yes, you need to draw it, I need to show so there's a 6. Okay, so this top line is the original problem. That's the 2/3 plus the 1/6. The bottom line is where we changed them to now be like fractions. Common denominator. Okay, it's super important. And that's it for the drawing. All right, let's look at number 5. So here we have 3/8 plus a 1/4. So I'm going to get 3/8 and a 1/4, and we're adding them. Clearly, different size pieces, different colors. I need to be the same size pieces. Well, I can't make 8s smaller to 4ths, but I can change a 4th into 2/8. And if you look at your list here, if I'm looking at a 4th, there's 1/4 here. It's the same as 2/8 or 3/12. Well, 12 doesn't do me any good here, but the 8 works. So that's what I'm going to do. So 1/4, I'm going to change to 2/8. And I'm going to keep my 8s. So now you can see I'm all same size pieces. I'm all same size color. So I just need to count how many I have now. I have 1, 2, 3, 4, 5 8s. 5/8 I cannot simplify, so that is it. That's our final answer. So now I need to draw the picture, draw the model. So, top line is the original. Bottom line is where we have the common denominator that we change it to. So, oops, I'm putting the line in the wrong spot. So I had 3/8 at the beginning. So I had an 1/8, an 1/8, an 1/8, and I had the 1/4. So then we kept the 8s and we changed the 4ths to the 8s. And there's our answer. All right, let's look at number 6. 3/10. So again, start with the model. Find 3/10 plus 1/5. Again, different color, different size pieces. We can't have that. We need a common denominator. So I'm not going to go tenths to fifths, but maybe I can change fifths to tenths. So if I look, it works. I can take 1/5 and change it to 2/10. So I have 1, 2, 3, 4, 5 tenths now, but I know 5/10 I can simplify, or if I look on my list here and I look at 5/10, 1, 2, 3, 4, 5, that'd be same as 4/8, but it's not simplified. 3/6, gotta keep going. That'd be 2/4, keep going, 1/2. So 1/2 is the same as saying 5/10. So I come up here, I can show you, if I divide by a special 1, it's going to be 5/5. I get 1/2, and there's our answer. So draw the model. So I started out with 3/10 and 1/5, and I changed the 1/5 into 2/10, which it means the same. So top is the original problem. Bottom is where we found that common denominator, the same size pieces. All right, look at number 7. We have 5/8 plus a 1/4. 4, 5, so 5/8 plus a 1/4. Again, not same size pieces, not the same color, not the same denominator. So we have to change it. So I can take 4ths and I can change them into 8ths. And I can clearly see it takes 2/8 to mean the same as a 4th. So let me find the rest of mine. There we go. So now you can see I'm all same size pieces, which is what we wanted. We're all the same denominator. So I have 1, 2, 3, 4, 5, 6, 7 eighths. I cannot simplify it. So now I just need to draw my picture. So I had 5/8, so 1, 2, 3, 4, 5, and I had a 1/4. The 4th we changed into 2/8. So now I can see I have 7/8, and I cannot simplify, so that's my final answer. Oops. All right, so for 8 and 9, I'm not going to do the models. I'm just going to put the answers on here. So if you are self-testing or trying it yourself, you have the correct answer. So number 8 would be 7/12 if you do it correctly. And number 9 would change to 11/12. And again, 8 and 9 are there for you to try to practice. All right, let's look on the back for the applies. So now, number 10. Alana walks east 4/9 of a mile to school every morning. On Saturday, she walked to a friend's house, which is a 1/3 mile farther east from her school. How far did she walk to her friend's house on Saturday? So I'm going to be drawing the models here. So I had 4/9 and a 1/3. Clearly, we're not same size pieces. So I can take my 1/3 size. And I don't think I have ninths. No, I don't. But I know that I can get to 9 on the denominator. So I know 1/3, and I want to get to 9. I can multiply by 3. There's that special 1. So I know 1/3 is the same as saying 3/9. So if I draw my common denominator one, I know that 1/3 is the same as 3/9. So there's a 9th, there's a 9th, there's a 9th. Oh, I made all those 4s and they need to be 1s. There we go. So now I got 1/9, 1/9, 1/9, 1/9. So now we can see I have 1, 2, 3, 4, 5, 6, 7 ninths. I can't simplify it, so that's my answer. So 7 ninths, and our unit we're looking in is miles. And that's it. All right, let's look at 11. Mr. Hawkins gets 2 bonus payments every year. This year, his first bonus was 1/4 of his salary. His second bonus was 1/8 of his salary. What was the fraction of his salary for combined, clue word, adding, bonus payments? So if I look here, I've got 1/4, and again, I'm drawing the picture. So I had 1/4 plus 1/8. And I kind of made it too big, so I don't need it all that big. So we'll erase that a little bit. All right. So clearly you can see the pieces are different. I know 1/4 is the same as 2/8. So I change it. So now I can see I have 1, 2, 3 eighths. I cannot simplify anymore. So the fraction representing his bonus payments would be 3/8. 12. At a gas station, Kurt asked for directions to the nearest town. The attendant told him to go 5/6 of a mile south and then 1/4 of a mile east. How far does Kurt have to drive to get to the town? So he's got 5/6 to go and then 1/4. So here's our 1/4. And then there's our, 1/6, 1/6, 1/6, 1/6, 1/6. So 5/6 plus 1/4. I can clearly see different size pieces. Can't have that. They must be the same. So I know 4ths and 6ths can use, or both change to 12ths. If I had a 4th and I look at a 1/6 piece, if I can find one, there it is. I can't just change a 4th to a 6th. They don't show the same size. Can't do it. Likewise, I can't take a 6th and change them into 4th because they're not the same size. So I need something that's going to give me same size pieces. And again, a 6 and a 4 would share a common multiple, a common denominator of 12. So we're going to get all those little 12th pieces. And so that's what we're going to change them to. And I'll show you. A 4th is the same as a 3/12. So clearly I can change it. And a 6th would be the same as 2/12. So I can clearly change all my 4ths and all my 6ths into 12ths, which is what we're going to do. So in my model, my picture, we just said it takes 3/12 to make a 4th. So there's a 12th, there's a 12th, there's a 12th. Oops. And a 6 is the same as saying 2/12. So each one of these 6, I'm breaking it into the 12ths. So now I'm all same size pieces, which is what you must have. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. But if I look, 9 12ths, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and kind of put my paper here. 9 12ths is the same as 1, 2, 3, 4, 5, 6 8ths, which I keep going, not quite a fifth, not all the way there. Ooh, here it is, 1, 2, 3 fourths. I can't go any lower, so it's the same as 3 fourths. And that's my simplified answer. So, five sixths plus 1 fourth would give us 9 12ths, but we're simplifying, so oops, 3 fourths of a mile further. All right, so again, remember in this section, lesson 4, hands-on, you're using the models, okay? If you do not have the models, then you need to draw them out, okay? Be very careful with this section. It's very easy to kind of get confused and lose your way. Try to remember what are the sames, okay? Meaning, if I'm looking at a fourth, I know a fourth is the same as 2 eighths, the same as 3 12ths. It's showing the same amount, okay? This might be helpful if you print off one of these and kind of look at it as you go as well. I hope you guys can go back and pause this and go back and try these and use the bars, use the strips to help you. And I'll see you guys next time.